Good day, M3. This is Teacher Win, and welcome to another unit of your science book. So this unit will focus more about waves. So for this video, we are going to learn about the different parts of a wave, and then we're also going to learn about the two types of wave, which is your transverse wave and your longitudinal wave. And we will also have word problem that is related to waves. So for more information, so you can read your science book on pages 67 to 72. If we talk about heat energy, your light energy, and your sound energy, so believe it or not, they are carried also by waves. However, those waves cannot be seen. So you cannot see light wave, heat wave, or sound wave, right? However, you can get the idea about wave by looking at a water wherein you can see there that the water is vibrating. So do you see this? We call it ripples. So you just imagine you drop a stone here, and then the stone here at the center will cause wave in the water. So from coming from the center, going outward, right? So we're in after the ripple passes, so the water settles back to its original level, by which the water itself does not move towards the end of the pond. So that means like it is the energy that is moving away from the center. However, the water here just simply just go up and down. So in the next slide, so we will be learning more about waves. So in science, we define wave as the periodic disturbance of particles of a medium. So if we talk about, okay, let's break these words. So if you say about periodics, so look at here the motion on the left side of your screen, right? So we have here the spring as your particles. Your spring here is like your particle, like your atoms, your molecules. And then we have here your medium. So the medium here is our spring here. So your spring here acts as the particle at the same time as the medium. So we're in as you move the hand either by up and down or by simply pushing the spring. So you can see here that there is movement in the spring, right? It's either the spring moves up and down, or just simply the spring is pushing, then stretching, then pushing again, right? So that up and down, and then the press, and then the relax of your spring, that is your periodic disturbance. Okay, so therefore in a wave, it's a combination of this up and down as the energy is moving to the direction. So in this picture, it moves to the right. So in this picture as well, down below, so the energy is also moving to the right. So a wave is movement of your energy from the source until to this end. As we learn more about waves, so let's try to read and understand some of these words. So please repeat after Teacher Win. Amplitude, amplitude, crest, crest, trough, trough, wavelength, wavelength, frequency, frequency, hertz, hertz, speed, speed. On the next slide, so we will be learning each word one by one. Okay, our first three words, we have amplitude, your crest, and your trough. So if you talk about your amplitude, so that means the distance from the highest position from the resting place. This one is your resting position. Resting position or resting phase, so that means the object is not moving. So if you talk about the amplitude, so we're talking about the distance from the highest to the resting position, or from the lowest to the resting position. So this is what we call your amplitude. So this one is amplitude also. Okay, so we're in your amplitude here, the highest point here is what we call your crest, and then the lowest point here is what you call your trough. Okay, so each amplitude, so they have its own special name. So if the highest position of your amplitude here, so this is what you call your crest. So the lowest portion of your amplitude, which is this part, is what you call your trough. Next, we have the word wavelength. So your wavelength refers to the distance by which a wave travels from one crest to another crest, or from one trough to another trough. So again, so this is what you call your crest, right? And then this one here is another example of your crest. So we're in your crest, from this crest going to this crest is what you call your wavelength. So that's the distance, right? Also, as what I've told you, so the distance from trough, this one is trough, right? And then this one here is your trough. So the distance between two troughs here are also called as your wavelength. Okay, so so in your wavelength here, so in other books, they use this symbol to represent your wavelength. Okay, so normally in wavelength, it can be measured. So the unit, it can be measured in meters or in centimeters. Okay, so if you might be asking, so what is the symbol? So we call it as your lambda. Okay, so again, a wavelength is the distance between a crest to another crest, or a trough to another trough. Okay, next is the word frequency. Okay, frequency or abbreviation is F. So a frequency is the number of wave, or shall we say the number of crests that passes a certain point in 1 second. So that means if this entire length here, if this length here until to this length, shall we say this one is 1 second. Okay, so in frequency you are asked how many crests does it create in 1 second. So as we can see here, so we have crest 1, crest 2, crest 3, crest 4. So that means in 1 second, in this picture so in this picture, so in 1 second, 4 crests are created. So therefore, the frequency for this drawing is 4. So normally, your frequency, its unit is in hertz or Hz. Okay, so that means na, so the number of vibration, okay, so the number of vibration for 1 second. So if you can still remember the word vibration, vibration is up and down, complete up and down. Vibration, if you can still remember your lesson about sounds in P5, so your vibration is your one complete up and down movement of a wave. So what did I tell you? So for this picture, the frequency is 4. What is the unit? So we're going to use 4 hertz. Okay? So I hope you understand about frequency. Okay, now let's try this example. So how many frequencies are here in 1 second? So you can pause the video and try to count it and try your guess if your answer is also correct. Okay, so it's time to reveal the answer. So as what I've told you, so frequency refers to the number of your crest. So in this picture, there are how many crests? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 crests. So therefore, how many frequencies in 1 second? So there is 10. Don't forget the unit, 10 hertz. Next is we have your speed. So as we all know, your speed refers to the distance an object is moving over a given period of time, wherein the speed here in your waves, it refers to the distance that your crest is moving in a given period of time. So we're in your speed, or abbreviated as your V here. So it can be expressed in meters per second, or it can be in centimeter per second. Now, I want you to think of this. Is there any connection between your speed, frequency, and wavelength? Okay, so the answer is yes, there is a connection. So let me just show you using these examples. So this is my resting position. Resting position meaning the object is not moving. So let's say this resting position, this is like in 1 second only. Okay, so just imagine this is A and B has the same length over 1 second. However, the amplitude is different here, or the frequency I mean. So 1, 2, 3, 4. In here, like 1, 2, 3, 4, 5, 6. So in here, so it's 4 hertz, right? Because this is 1, 2, 3, 4. In here, we have 1, 2, 3, 4, 5, 6 hertz. Okay, so as you observe here, so if you talk about your 4, if we look at here the distance, right? The wavelength here, the wavelength is bigger or wider compared to your 6 hertz, right? So meaning, if you have here a bigger hertz, so that means this object here is moving faster than a smaller number of hertz, which is a bit slower, right? So here's the point. So as the number of frequency is increasing, okay, so its distance from crest to crest, or its wavelength, is getting shorter, right? However, if the frequency is getting smaller, so that means the wavelength also, or the distance from crest to crest, is also getting lower, na? Or I mean, it's getting bigger. So that's why in your speed, so we can express it this way: speed is equals to your frequency multiplied by your wavelength. Or we can just simply say speed is equals to frequency and your wavelength. So this is the formula that we're going to use if we want to know the speed of your wave. So this is the summary of your wave M3. So origin is like the source of the object that is being shake. And then we have here the amplitude again. So amplitude is the height of the wave. So also we have here the wavelength, which is the distance of crest and then the other crest. Or it can be from trough to another trough. Okay. And also your frequency. So frequency in 1 second is you're going to count the number of crests that is given in a certain picture. Okay, now there are two kinds of waves. We have your transverse wave and your longitudinal wave. So let's begin first with your transverse wave. So basically, if you look at the picture, so this is your slinky spring. Okay, so this is your slinky spring. So looking at the picture, so in your slinky spring, so the object is just moving up and down. Okay, so as this energy is transferred from the hand going to the end part, so the slinky spring just simply go up and down, right? However, this area of your slinky spring stays here as it goes up and down, right? It does not go to this part, right? So, in short, in your transverse wave, the object will just simply go up and down, but not necessarily moving from this point to another point. It is just the energy that is transferred as the wave is going up and down. Okay? So again, so in a transverse wave, so it is a wave that moves up and down as the energy is moving from one direction to another. Next is we have your longitudinal wave. Now, in your longitudinal wave, so if you look at the animation here, we can see that the person is just pushing the slinky spring, and then what happened is that there is an area that is like relaxed, and there's an area that is like there is a high pressure on it because they are so close together. So in your longitudinal wave, so there are several parts again. So please, let's try to understand, or let's read some terms. So we have here this so-called your rarefaction. Your rarefaction. So where is your rarefaction? So your rarefaction is this area. So this is your rarefaction. So your rarefaction is like, this is like the low pressure area of your spring, meaning something like the relaxed area of your spring. This one, this very close together, this is what we call your compression. Compression. So in your compression, so this is like the high pressure area of your spring, wherein this high pressure area will cause that energy to move to the next area. So without compression, so the energy will not move in another spot. Na? So again, so in your longitudinal wave, so there is an area of press, relax, press, relax. So let me just read this one. So longitudinal wave, so it is a wave in which the particles oscillate. Oscillate is vibrate. Okay? Vibrate parallel to the direction of wave and energy transfer. So it means it compresses, it relaxes as the energy is moving from this picture from left going to the right side. So in longitudinal wave, we still have here your wavelength, even though it is not moving up and down. So wavelength here is defined as the distance between compression to another compression, or it can be a distance between a rarefaction to another rarefaction. Okay, now let's use these word problems to understand more about waves. Okay, so a wave produced in a rope has a frequency of 3 hertz and a wavelength of 50 centimeter. So what is the speed of the wave? Okay, so let me help you by drawing this one. So a wave, so we have here your resting position, and then a wave has produced in a rope with a frequency of 3 hertz. So that means we have 3 crests here, right? So 3 crests, so that will be like 1, 2, and 3. Okay, so I'm sorry na if my drawing is not that good. So my point here is this one, crest 1, crest 2, and crest 3. So this is 3 hertz. And a wavelength. So remember that the wavelength refers to the distance from crest to another crest. So that means this crest here, and then this crest here is 50 centimeter. So from this crest to another crest, so this is another 50 centimeter. So this is what your problem looks like. So a wave produced in a rope has a frequency of 3 hertz and a wavelength of 50 centimeters. So what is the speed of the wave? So let's have first your given. So your given value here is we have here your speed, and we don't know, so you have your x. So next is we have your frequency, which is your 3 hertz. And then we also have here your lambda, which is your wavelength, which is your 50 centimeter. Now, what we're going to do is we're going to use this formula to get the speed, right? So we have here your speed is equals to frequency multiplied by your wavelength. So M3, if you look at na, there are three variables in your formula. So therefore, we can just simply use also the triangle na. So the another triangle here. So we can have this one is your speed, this can be your frequency, and this one is your wavelength. So you can use this triangle to know the different value of each variable. Okay, so what will be our solution? So we have your speed is equals to frequency and then your wavelength. So your speed is x, we don't know yet. So we have here your 3. I will remove the unit for convenience and then multiply by 50. So 3 times 50, so you will get around 150 centimeters per second. So this is the value of your speed. So meaning this wave here that is 3 hertz with a wavelength of 50 centimeters, so it is moving at a speed of 150 centimeters per second. Okay, so let's move now to our problem number 2. So a water wave are normally produced by tapping a water surface in a ripple tank with a pencil. So it's just like this. If this is like your ripple tank, this one is a pencil, right? So if this one is a pencil, so inside here we have here your water, right? So tapping meaning hitting this drum, so it causes the water to to vibrate, oscillate, or to create waves. Okay, so if the wave travels 1.2 meters in 4 seconds, so what is the speed of the wave? Number 2, if the frequency of the wave produces 3 hertz, find the wavelength of the wave. So we will be separating each problem. Okay, so let's start first with problem A. So we know already that your speed can be acquired by having your frequency and then your wavelength, right? However, if you look at the problem, we don't have the frequency or wavelength stated. And remember also that there's another way to get your speed, right? So speed can be get by computing the distance an object or the distance traveled by an object in a certain time, wherein we can represent it as your distance over time. So by which we can see the two values here. So let me just write it here as a given. So your speed here, which is unknown, then the distance is what? 1.2 meters. And then the speed is 4 seconds. So the formula that we are going to use is not wavelength multiplied by frequency, but we will use the distance over time. So what will be our solution here? So our solution that will be speed is equal to distance over time. So the distance is 1.2 meters divided by your 4 seconds, and you will get an answer of 0.3 meters per second. So this will be our final answer. Okay, so your wave that is traveling 1.2 meters in 4 seconds, so the speed of the wave is 0.3 meters per second. Okay, now, so for our example here, so we have here the given frequency, which is 3 hertz. We have to find the value of your wavelength. So our given here will goes like this. So we have here your speed, which is 0.3 meters per second. We also have here the value of your frequency, which is 3 hertz. and then the value of your wavelength, which is your unknown. So for the formula that we are going to use, so I want you to use again the triangle M3. So we're in your triangle, this one is V, this one is frequency, and this one is your wavelength. We want to know the value of wavelength, so we'll just simply look at the triangle. V is on top of F, so this is division. So V, or speed, divided by your frequency. So for our solution here, so that will be lambda divided by speed divided by frequency. X is equals to 0.3. I will remove the unit for convenience. Divide by 3. So that will be how much? Okay, that will be 0.1 meters. So that means that your wavelength of this wave is about 0.1 meters. So in our scenario there, if your wave is traveling at 1.2 meters in 4 seconds, so that means for every second it travels around 0.3 meters, right? So in this scenario, if this is 1 second, we have here 1, 2, 3 hertz, right? So this is 3 hertz because there are 3 crests here. So the wavelength for this one, I mean the wavelength meaning the top. So here and here, the distance is 0.1 meter. Also here and going here is also 0.1 meters. So also here, the trough to the trough, then the distance is also 0.1 meter na. So this is what your wave looks like after computing the speed, the frequency, and the wavelength. So this is the end of the lesson for this video M3. So I hope you understand about waves. So I have a homework for you, so please do it. Write it in your science notebook and send it to the Google Classroom. So once again, thank you very much for listening and have a nice day.